welcome back again to design of steel structure. If you are new here, don't forget to subscribe and click on the notification ring bell for getting all the notification about the new videos. So in the previous lesson or the previous lecture, we talked about the introduction to steel structures. We explain a bit about the overview of steel structures, and today we're gonna continue with the introduction to structural design. As we move forward in the design of steel structure after the introduction, we'll be going step after step and to design and discuss more about the steel structures. Today we're gonna talk about the requirement. In every structure design, when we design a structure, there's a certain type of requirement that the structure needs to meet before we accept or we validate the structure. And among the requirement of the structure design, we have functionality, serviceability, safety, constructability, and economy. These requirements are very important. For instance, when you talk about the functionality, the engineer should choose a suitable structure type for meeting the client need. And the structure type the engineer is going to select, it depends on the project. If it's a building project, if it's a transportation project, tunnel, subway, or all the engineering project. And talking about the serviceability, the structure must be designed to function properly during its anticipated service life. When we design a structure, there is a certain service life that we design a structure for. And this service life is specified in the code or the building standard. It can be 50 years, it can be 100 years, it can be 10 years, and so on, depending on the standard we are using. This technically means the structure should function in elastic range with no permanent deformation. When I mean permanent deformation, those are the deformation that are not reversible, but no excessive deformation or undesired vibration should occur also during the service life. All the structure that we design, we make sure that the structure function in elastic range. So the structure must be designed also with sufficient strength and stiffness to resist the design load and have enough reserve deformation capacity to maintain life safety under possible extreme load. When we design a structure, we define a certain type of load, but this load and the probability to occur at a certain time is very low. And we use a certain type of combination to know what combination will be the unfavorable one, and that is the combination we use for design. But using this type of combination, we have to make sure that the structure is designed and provide a sufficient strength to resist during its service life. So this requirement can be attained by a combination of good design, good workmanship, and good construction method. The design here we refer to engineers and the institution that are responsible for the design of the structure. And the workmanship, it depends on the technique you use, the worker that you're gonna employ to go through the project and construction, and also the construction method you're gonna use. Talking about the construction method, it depends on different countries and how the countries are developed so that they can implement the advanced construction method. The structure should be also designed with simple forms and feed connection that can be built within the skill level of the local force. We design structures, but we consider also the local workforce we have so that we can implement all these elements, the design and the workman force, to complete the construction of the building or the structure during an acceptable time schedule. A good design results in both low initial costs and low maintenance costs. This time we are talking about the economy. Being a structure engineer is not only about designing a beautiful structure or designing a strong structure and safe structure, but you have to design also one of the economic structure, because it's about competition. You have a project, but a client will choose your project over others if your structure meets all the requirements I mentioned before: functionality, safety, serviceability, constructability, and economy. Those are the elements we have to take in account and then try to make them so that they match all together to produce a good design result. Talking about the building code, as I was mentioning, and the specification, a building code is just a board-based document that provides a framework of minimum requirement for building design and construction, and it's different from one country to another. These building codes are the documents that are published maybe every year, depending on how developed the country is, by the government. It can be also the local building code depending on which city or different cities, but in the same countries. The building code generally addresses all facets related to occupant safety, such as structural design, architecture detail, fire protection, heating and air conditioning, plumbing, sanitation, and lighting. In the building code, they specify everything an engineer, structure engineer, electrician, architect, they have to know or they have to follow before starting a project, because everything that are specified in the building code have been checked and verified by experts and institutes that are specialized in that domain. We have also specification for structure steel building. This one, the 1989, the allowable stress design and plastic design. 2001, load and resistance factor design specification for structural steel building. ASC, ASD, AST, and all of these are just the example of building code used in construction. But the building code also take a different aspect. They can be for wood, they can be for transportation, they can be for construction, steel structures, they can be for reinforced concrete. But the most important is to have a look on this building code before starting any kind of project. Talking about a specification may also refer to a group of rules set forth by architect or engineer that pertain to only one particular building during construction. For instance, this specification for structural steel building, you see, this is a specification that came out from a building code. It can be international construction building, that is the main building code, but from that main building code they came out with a specification related to structural steel building. It is a particular importance to note that the codes regulate the minimum design load to which the structure is to be designed. The load that are specified in the building code are just minimum design load that a structural engineer can refer to when you want to design a certain building or in a certain project. But when you are on site, considering also the real problem, as some engineer, they have some experience, they can also use by followed by the experience, they can try to judge if the load, the minimum load that is specified in the code can be used, or they can also adjust them by themselves depending on the situation they've been through or the experience they have. As I can show you from this specification, as I was mentioning before, we see we have the standard code. Different countries, they have the different building code, and that is the one they use for the construction. For instance, this is a software engineering software for designing a global airframe. I can select a standard here. We have Eurocode 1990, Eurocode for timber, for crane, for geotechnics, ASCE, this is American code, IBC, Canada, Brazil, India, and all this code. This is Chinese code, South Africa, Italy. All of these are the specification of those specific countries. You will see here we have Eurocode. Eurocode is one of the standards they use in Europe and all the European countries, but they may have also some specification related to some local cities or local provinces. We have also the national annexes that come out of this standard building code. Now for specific countries, for instance, we have here Germany, Cyprus, Denmark, Greece, Ireland, and so on. So all of these building codes, you have to understand them, and then you have to consider them before you start a design. These building codes are actually our law, our standard in structure design. We have to follow them before we start any kind of project. We can continue now by saying a specification is usually developed by a group of experts. As I mentioned, it is intended to guide a designer in producing a safe and economical structure. For instance, the AIC, American Institute of Steel Structure, they can be modified, reflect to the recent development. All of this building code, they started from somewhere. But you can compare the first edition they published to the latest one. You will see that there is a difference, or there are changes that have been made. These changes, they are made because of the development or the change of climate and everything. The development of the technology and all the methods that have been improved. The more they improve the method, the more they update the building code. Because the one they wrote in the earliest, maybe 19th, they wrote them according to the method of construction they were using at that time. But this time, the method have been really developed and the technology is very advanced, so the building code has been also updated. This is Eurocode. We can see 1990, 91, 2, 3, and Eurocode 1, 2, 3, 4, 5, and so on. Basic structure design. This is for action on structures, design of concrete, steel structure, composite, timber, masonry, and so on. We have also, this one is a Chinese standard. It has different letter, GBT, depending on which one we are using. For instance, I can take CECS construction. This one is recommended. We have all the industry sector have their own building or their own standard. In construction, we say building code because we are talking about building and construction. But in other industry, I don't know, they will speak about maybe according to the technology and the lexic. Now we're gonna talk in this third point. It's very important as a structure engineer to know the loads that are acting on a structure, or the load that will be subjected to a certain type of structure. A structure load is a force. It can be a force, deformation or acceleration that is applied to a structure element. But this load will cause stress, deformation, and displacement in a structure. Now, a structure engineer will do a structure analysis to analyze the effect of those loads on a structure and the structure element. The loads are applied on a structure. When the loads are applied on the structure, there will be some stress and deformation that will be developed in the structure element. When I speak about the structure element, it can be a certain rectangular shape of reinforced concrete. It can be C-channel, I-beam section. So we have to analyze those effects and to make sure that the strength and the stiffness of those elements that's enough to resist the applied load. The type of load that are applied on a structure can be dead load or permanent load. These dead loads that include the safe weight of the structure members, the partition or equipment if you are talking about building, sealing and finishing. But if you are talking about road and other type of domain, it may change to other type of dead load. But you have to know that the dead load are the permanent load that will be there on the structure during all its service life. The live loads are the load that can be changed or that can be removed. They are just applied for a certain time or a specific moment, and they can be removed later. We have human occupant, furniture, movable partition, and storage. For instance, in a building, people can be in a certain classroom to attend class, but after class, the student will go back home. When they were attending class, those live load were applied in that room, but after the class, the student have left and the load is not there anymore. I can maybe explain this one through. These are the live load. The live loads that are applied in this room. For instance, this is the live load that is applied in this room for a particular moment, but in this other room there is nothing. So if you want to do the analysis of this room, we will consider only the load is applying on this room, because in this room only the deformation will be on this area, but this area there is nothing that is happening. Although there will be a small influence of this load, but the deformation will not be that strong or be very big. That's why the live load is the load that can be applied for a certain time and then it can be removed. Due to the concern for public safety, minimum live loads to be used in the design are usually prescribed in building code of the country. They will tell you, for instance, if it's a type of structure, for each type of structure there is a specific live load to apply for this type of structure. For hospital, for school, for kindergarten, for public work, public places and dormitories, all of these building or this type of structure, the specific live load to use are specified also in the building code. But since the probability of having the prescribed load applied uniformly on a large area is very small, so a reduction in live load is allowed. In some design code or some building code, we specify the load, and they will also explain if you want to apply a reduction, which factor of reduction you have to use for a certain type of live load. And these reductions are also, they depend on the type of structure you are using or you are designing. Any live load that can have also a dynamic effect on the structure should be increased by dynamic load factor that is applied to the static load. During the construction, there must be some movable crane or machine in the construction site, but this movable structure, they can have some influence on the surrounding, that may be the construction of the building. So during the design, there's some dynamic factor we have to consider if you know during the construction this type of condition can occur. So these factors also are specified in the construction building code. Depending now on the environmental load, we can have the wind, earthquake, snow, soil pressure, and rain. The environmental loads are very important to consider during the design, because the wind that we will consider in the north will not be the same that the one we consider on the south or in the west and east. So this one also are very specified in the building code, but specifically in the local provinces or local places where the building or the project will be constructed. And the earthquake also, the earthquake is considered depending on the area. If your area doesn't have any earthquake, so you don't need to consider earthquake during the design. The same way for the snow, some region or some countries, they don't have this winter season where it's snow, so they don't need to consider snow during the design. But the soil pressure and the rain may be also very important during the design to consider among the type of environmental load we use. So this is just a picture of different type of load that are applied on this specific building and the way this load are transferred to the structure. So on the roof we can have, maybe for the rain can fall here and then it will maybe stack on this area or infiltrate in the soil and become a pressure, hydraulic load. But for the snow, most of the time, if the snow is heavy, it will maybe stack on the roof for a moment until it's gonna melt and then fall down. But during that time, when the snow is stuck on the roof, it's bringing us an additional load. So during the design, if you are in the area that has winter and then you know that there is a probability of having snow, we will consider the snow as a live load. So during the design, we have the dead load here. We have a partitioner, we have equipment and people. We have also the partitioner wall, like the part of the dead load as I was mentioning, and then the furniture on the ceiling. There can be the lights, the pump and all the equipment for plumbing that we include in the ceiling. Here we have the pressure of the soil acting on this underground foundation, and here we have the water. The water collected from the roof that is stagnant in this position that can be also an additional load for this slab, and then we have to consider also it and the design. This is also one of the picture that explain how the load is transferred from a surface to the foundation. First of all, the load is applied on the surface, and if the surface is supported by the beam, this load, that is a surface load, will be converted in a linear load or a distributed load. It can be also a concentrated load. This load will be transferred first to the beam, and the beam will carry the load. The beam on its turn now is going to transfer the load from the column, and the column transfer the load to the foundation. The foundation again is going to transfer the load to the ground, that is the supporting ground can be the soil, but the soil must be strong enough to resist the load that is coming from the upper structure. That's why we do some experiment on the soil to find the bearing capacity of the soil before starting any type of construction. So this was all about today. Thank you and see you next time. But before I close, so I can also bring some of the recently published standard Chinese code. These are also one of the recently published standard code. For instance, here, they're in Chinese. This one is for steel structure. This one is for steel structure. I can open it and then show you. Yeah, this is one of the Chinese code for the steel structure design, and we have this one also for construction, this one also for reinforced concrete, this one for timber structure, this one is for masonry structure, this one is for composite structure, beam, steel and reinforced concrete. So if you have any question, don't hesitate to write it in the comments. Thank you.